Oh, well, good afternoon, and thank you for inviting me to speak today about some of the kinds of biases that creep into the modeling process. This is an extensive topic and has been and continues to be the subject of a lot of debate and research. My presentation will highlight consensus around biases that impact each step of the modeling process, and then examine some historical sources of bias that still influence underwriting data today. So I'm going to go through some sources of bias in algorithms, talk about the NIST iceberg model, look at some bias identification in the modeling process, and go through some examples of bias impacting AI models, and then talk about the key to bias mitigation, and that's strong governance. So when we look for sources of algorithmic bias, there are lots of places to look. In the organization, within its business policies and practices, in the statement of the problem and measures reflected in the algorithm, in the data, there are lots of biases, and we'll talk about that in great detail. I often say the model is the innocent bystander because it's based on math, right? And math is always right. Wrong. The math can be the wrong math for a problem, and the algorithm is the tool that amplifies the bias in the data. Finally, the model may not be implemented as intended. This can easily happen when there is little human oversight or uninformed supervision of the model. So the iceberg metaphor is used to explain a lot of phenomena. The National Institute of Standards and Technology uses it to talk about three categories of bias: statistical, human, and systemic. Using the iceberg to represent these categories has two meanings. The obvious one relates to visibility, and the second relates to the difficulty of mitigating those biases. So most people think statistics is hard, but in respect of bias, statistical bias is often the easiest to see and the easiest type to resolve relative to the other two. Human biases are just below the waterline and are more difficult to resolve than statistical biases. My mother had this saying. She said, "You can't change people, they have to change themselves." And that is the challenge with human biases. People have to recognize their biases and actively work to change them. Finally, there is systemic bias. Systemic biases are so deeply ingrained in our institutions and society that it would take Herculean efforts to eradicate them. History books are a good example of this, because not every group is equally represented and accurately represented in history books used in schools, certainly in the US. I'm not sure about other countries, but certainly in the US we find that's true. So this slide kind of gives you an idea of where we've been and where we're going. It used to be that when we did underwriting, we were underwriting based on who people are. You know, we used traditional methods. It was very paper-based. Humans were involved, lots of traditional data sources. We relied on the agent a lot, and it was very line of business focused, Excel-based, and we had lots of assumptions. Now with AI, we're looking at a broader set of services, and we're really focused on how people behave. And that's why understanding human behavior is very important to mitigating bias in algorithms. We have these machine learning methods. We see it in automated algorithm where oftentimes there's no human involved. We see all these new sources of data, which is causing a lot of problems for regulators in the US because those sources of data are not regulated. And there are definitely sourced from a wide variety of channels, and it's more whole customer focused. So when we talk about algorithmic bias, this really deserves some attention because it's a relatively new term that we've seen a lot of people talk about in the US and confuse. And this phrase is increasingly being used to describe bias. And it's getting treated as either an umbrella term for all biases or as a bias distinct from cognitive or statistical bias. It really is improper to afford the phrase either treatment. This phrase, as I said, is relatively new. It was given birth to in the 1980s. And the medical school in this story learned that algorithms reflect human biases and that resolving biases in algorithmic outcomes can be achieved by resolving biases in human behavior. And IBM, I think, really perfectly clarified the meaning, and I'm not saying that just because there's someone from IBM here. But they talk about the algorithm as the vehicle through which biases pass. And so biases, because these biases, they can exist without an algorithm. That's why I think the term algorithmic bias really needs to be well understood. Biases in algorithmic outcomes, they result from biases in the training data, the algorithmic design, the proxy data, and the evaluation of the algorithm. So as I previously stated, I'm going to highlight some of the biases that creep into every stage of the modeling process. I think this diagram is a really nice depiction of the modeling process. It starts in the logical place where model development begins, and that is understanding the business problem needing a model, and it ends with deployment, the point at which the model becomes operational and starts to affect the lives of real people. We're going to walk through this process and discuss some of the different types of biases that can impact decisions at each stage. So the first group is statistical bias. And as you probably recall, one of the first definitions a student of statistics learns is that of an unbiased estimator. An estimator is represented by the E symbol in this picture, and we are saying that our estimate is unbiased if over the long term it can predict the population parameter. Well, this is the same definition and the spirit adopted by the International Organization for Standardization, which defines bias as the degree to which a reference value deviates from the truth. When the deviation is 0, there is no bias but by this definition. However, it's important to remember that statistical bias is a quantitative calculation, not a qualitative calculation. Even if this bias calculation is 0, the model can still harm consumers. We're going to talk about sampling bias, selection, measurement, and omitted variable bias because these biases are often found in the training data. And the training data is one of the two primary categories of bias in modeling, with the other being biases imposed by the modelers. So it really sounds easy to take a random sample. How could anyone mess that up? Well, the truth is you can. I mean, you can certainly get a sample that is leaning towards one value in the data. And so we would say that that data set is biased. But we can easily correct that problem because we can just resample. Selection bias occurs when you select your sample from the wrong population to define a metric and use that metric to make inferences about the larger population. So for example, taking a sample from the population of basketball players to make an inference about the average height of the general population would reflect sample bias. Our estimate would likely be too high. The general population would have been the better population from which to draw the sample. Measurement bias can occur as a result of bias in the training data, where certain groups are not represented in the development of technology, such as was true with the pulse oximeter when reading darker skin during COVID. The instrument was not trained on dark skin and gave faulty readings on dark skin. Measurement bias can also occur when faulty measurements result in data distortions. Target variables can be ill-defined for the purpose of the model, which is what we saw when a health company attempted to predict the need for medical care referrals using medical spending as the target variable. And the result was biased against people who had very little access to health care. The algorithm ended up referring people with little access to health care less for needed critical care than it did for those with more access to health care. Finally, omitted variable bias occurs when an important variable is left out of the model. Omitted variables can often explain spurious relationships. So this is the Cognitive Bias Codex. And it's a useful tool for visually representing most of the known cognitive biases to date. The biases are arranged in a circle and can be divided into 4 quadrants. Each quadrant is dedicated to a specific group of biases. You can find the interactive version of this codex on the internet, which I highly recommend you do. You can learn a lot about the different types of biases that may be impacting the work you do. However, the word bias has really become synonymous with the word bad. But as humans, we need biases to help us make sense of the world. And as we will see in examining the quadrants of the codex helps us understand why we need cognitive biases in our life. The first group of cognitive biases helps us understand what we should remember. We as humans can only afford to keep around bits of information that are most likely to prove useful to us in the future. We need to make constant bets and trade-offs around what to remember and what to forget. For example, we prefer generalizations over specifics because generalizations take up less space. The second category helps us filter information because we're bombarded with so much information on our daily lives. And the third represents biases we employ when there's not enough information. This is often results when there is missing information. And sometimes filling in that missing information helps us understand a problem, but sometimes we can fill in with very harmful information. And the last is employed when we need to act fast. Certainly as humans, we're constrained by time and information, and yet we can't let that paralyze us. Without the ability to act fast in the face of uncertainty, we certainly would have perished as a species long ago. So with every piece of new information, we need to do our best to affect the situation, apply it to decisions, and simulate the future to predict what might happen next, and otherwise act on new insights. Groupthink bias, I think, is one of the most important biases to be on the lookout for in organizations. Because an American writer, Walter Lippmann, said, "When we're all thinking the same, we're not really thinking." And sometimes you can have groups where there's one voice that is more dominant than another voice. And sometimes the person who's afraid to speak up might have the best idea. So in corporations, we really need to make sure everyone has an opportunity to speak up and feel comfortable speaking up. Confirmation bias I think this graphic really helps capture that meaning. And this bias occurs when only some facts are considered, those facts that intersect with our common beliefs. Again, this type of bias is dangerous in the modeling process because we may fail to consider a solution that is very viable. Deployment bias, this happens after the model gets deployed. And oftentimes what you see in organizations is the people responsible for implementing the model often have no idea how the model was developed. And they're just using their instinct or just simply following directions. Sometimes their instincts are really good that they should not do what the model says. And you have to make sure people feel empowered to raise their hand and say, hey, I don't think what's coming out of this model makes sense. And someone needs to come over here and look at the results. So let's look at some use cases. I did a while ago allude to an algorithm, a healthcare algorithm that used the wrong metric in its model to figure out which groups of people should be targeted for specialized referrals. And it turned out that because in the US, the way that society works and some of our social policies and practices is difficult for certain groups to get equal access to health care. And so the more dominant groups have better access than some of the less dominant groups. And so when this company used healthcare spending as a proxy for whether or not someone should be referral, it didn't account for the fact that some people just didn't have access to health care, so that metric was actually flawed. And that was a societal thing. It really didn't have anything to do with the math. If everyone had the same access, the math of the metric would have captured correctly the need. But the problem had to do with that systemic bias that actually altered the data. And then there's the Amazon hiring algorithm. This is another example that's often talked about. And this algorithm discriminated against women in hiring. The algorithm didn't actually get used, but get into production. But the problem with the algorithm was it was going by things on resumes, like what colleges women attended. And there's also this idea that women use different words on their resumes than men. Because women are so nurturing, they were using words more like collaborated, assisted, helped, whereas men were using words like captured and executed. And so the algorithm was picking up on these social cues that were embedded in the language of resumes. And the fact that the resumes that were used in the algorithm were also reflected the company's hiring patterns, that really didn't help. So after a lot of criticism, the algorithm was eventually scrapped. This is I'm sure some of you have these wearable devices. A bunch of you have some on right now. You see that little green light behind your device? That green light technology is also known to embed bias in the data and influence the way it functions. Because again, green light technology doesn't penetrate darker skin the way it does lighter skin. And so this was really a problem when you were trying to use it to measure certain biometrics. Then there's selection bias. I really do like this story, about this guy who worked during World War II. He was studying Abraham Wall. He was studying what they should do to strengthen certain areas of the planes. But just by looking at the planes that came back, that was, again, kind of a biased approach, because those planes came back. They had to then think about, well, where were the bullet holes on the planes that didn't come back? And so that when he made that realization, they said, okay, we need to reinforce these planes in different areas. But insurance data also suffers from selection bias in that we take insurance data and we tend to build models on data that we already have. But that data already reflects selection bias because those are the people the company wanted to take in the first place. And so we keep compounding the problem by using the same data over and over to generate new models. So one thing, and this is something I think is very important for people to think about, and I give myself credit for this quote, that bias in data is the result of human activity. If you can understand how your data was generated, you are likely to be able to figure out whether or not bias actually got into that data. So we often talk about a bias generating process, like if you only put green pegs in a box, and then you say, I want to study the colors in this box. Well, you're going to have some selection bias there because you only put one color in the box, and that's not going to necessarily represent the entire world. But we see that bias, is in all of the different operations of insurance. And these are just some of them. And we found this out in the US, the NAIC did, by conducting surveys on life, health, and P&C product lines. And we learned a lot from insurers about where they were seeing bias throughout their operations. So the key to mitigation is really strong governance, and I think we were having this conversation earlier. So I represent the Society of Actuaries on the International Association of Actuaries AI Task Force, and one of the things we were tasked with was coming up with an international governance standard. And so we did work on that. It is now in its final review stages, and it should be published on the IAA website later this year. So in a really short time, we have seen how AI governance has really been regulated as a regulatory and industry necessity, not just in insurance, but with practitioners and regulators alike realizing that governance is not the enemy of innovation. So that's the first thing we have to remember. Governance is not the enemy of innovation. It is a catalyst for its sound development and keeping ChatGPT honest. Bias is a word that dates back to the 1950s when the French introduced the word. And it was likely had some other usage before that. But this word has really taken on a different meaning now that we're talking about AI. There was a time when everyone understood what this word meant. But now that we have artificial intelligence, we're all questioning, what does bias really mean in the context of an AI model? It still means the same thing before AI was around. So we can see that governance is really important, and with a strong governance framework, data and models can be, without one, data and models can really be susceptible to misuse, whether it's intentional or not. And errors and weaknesses may not get addressed. And there may be a lack of consistency in insurance products, processes, and services. Finally, the work group felt that governance should address regulatory expectations and requirements. So I know I'm getting close on time, but the framework actually covers these 10 components. And so when the paper comes out, I highly encourage everyone to take a read through that model. It also walks you through the AI life cycle of a model. And again, it provides a lot of guidance on, how to, what kinds of policies you might want to instill in your organization. And there are also a lot of analytical tests of bias. I'm not going to go through all of these, but what I wanted to actually give you a sense of for what all of these methods are doing if you take a look at this picture, like the Kolmogorov-Smirnov test, I've always loved that test. You can see you've got two groups of people, and one curve represents one group, the other curve represents another. Now, in this picture, we would say that the model created some bias because the two curves are not superimposed on each other. If the two curves were superimposed on each other, there would be no difference between the two curves, and we would say no bias exists. All these other tests, they actually function in a similar way. They just use a different metric. And so you might want to think about how to conduct a bias analysis on your model. And these are some general categories and metrics that you should think about. There's some general fairness metrics. What's the objective of the model? Bias thresholds need to be established. Looking at your data, think about any links to discrimination, any kind of historical bias that might be present in the data, how old the data is. Some people are still using data that's 20 years old. That's too old. We have models, treatment of offsets, there's inter-rater reliability, especially with like convolutional neural network models that involve like human coders, sensitivity analysis, and as well some social systemic issues, just like the one I pointed out earlier. So one of the key things with mitigating bias is really training and education. And no one in the organization should be left out. From the top of the house to the first rungs of the organization, it is especially important for those on the first rung because, as I said before, a lot of times we take these models, we create dashboards, and people who have to implement a lot of functions in a company are relying on these dashboards to do their work. So again, the training should include training them to recognize when the algorithm is producing illogical results and give them the power to say, I'm going to pause, I'm going to stop, and go ask someone to take a look at these results to see if they make sense. And finally, education is just not a one and done exercise. It must be ongoing, and its effectiveness must be measured to ensure understanding and compliance with the provisions of your AI governance framework. Thank you. I wish we had time for questions, but I'm told I am almost 2 minutes over.
It's okay. 네, 여러분 박수 부탁드리겠습니다. Thank you very much, Dr. Dorothy Andrews, for your keynotes.